I've been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
In this video, we're going to look at solutions to linear inequalities. The solutions are the set of ordered pairs that make the inequality true. So we're going to look at a couple examples here. Y is less than or equal to negative 1/2 x plus 5. And we need to determine if the following points are solutions to the inequality. And so one way to do that is simply by plugging it in. So I'm going to plug in for option A, I'm going to plug in a 1 for x, so negative 1/2 times 1 plus 5. And the 0 is in the y, so 0 is less than or equal to. Now what we're doing is we're trying to figure out if this is true or not. So negative 1/2 times 1 is negative 1/2. I'm going to write it as 0.5 plus 5. Negative 0.5 plus 5 is 4.5. And 0 is less than or equal to 4.5. So this one is yes, it is a solution. Let's look at the next one, 8, 3. We're going to plug in the 3 where the y is and the 8 for the x. And we're going to simplify. 3 is less than or equal to negative 4 plus 5. Negative 4 plus 5 is 1. 3 is not less than or equal to 1, so that is not a solution. Lastly, negative 4 is 7. So 7 is less than or equal to negative 1/2 times negative 4 plus 5. Negative 1/2 times negative 4 is positive 2 plus 5 is 7. So is 7 less than or equal to 7? Yes, it is because it's equal to. And again, that is less than or equal to. Can't be both. It has to be one or the other. It fits that inequality. So yes, this would be a solution to the inequality. Now, real quickly, I'm going to show you what the graph would look like so that you can see where these points lie. So remember, because it's less than or equal to, it is a solid line and it is shaded below. And so let's go ahead and plot these points. 1, 0 is right here. You can see that is in the solution set. 8, 3 is right here, so you can see that is not in the solution set. And negative 4, 7 is right here, which you notice is on the line. And because the line is solid, that is a solution. So the points on the line will not always be solutions, only if it is a solid line. So a couple different ways you can check if a point is a solution. You can plug it in, or you can look at a graph and see what it looks like there. Let's look at a second example. Negative 5x plus 2y is greater than negative 10. So for this one, we're going to actually graph it first and look at where the points lie, and then we will figure out if they're solutions or not. So we're going to graph this line using the intercepts because it is in standard form. So negative 5 times 0 plus 2y is greater than negative 10. So this cancels. So y is going to be negative 5. Now, you know, the inequality says greater than, but remember, we're just graphing the boundary line. And so the y-intercept of the boundary line will be negative 5, which is right here. And now we're going to find the x-intercept by plugging in a 0 for y, which is going to be negative 5x plus 2 times 0 equals negative 10. So we divide by negative 5, x equals 2, which would be right here. So there's my 2 points, and I can see from here that my slope is up 5 over 2. So I could continue that pattern and make my line a little bit better. Now notice that the inequality symbol here is greater than, and so our line is going to be a dotted or a dashed line. It will not be solid. So our line will look something like that. So now we need to figure out where our shading would be. And so it says greater than. Now I want to point something else out. Because this inequality is in standard form, we need to be careful to make sure that we shade the right part. So we need to make sure, in other words, that we didn't have to divide or multiply by a negative. So if I were to solve for y, I would add my 5x to both sides. So 2y is greater than negative 10 plus 5x, and then I would divide by 2. So we're good. It's going to still be a greater than symbol. So I'm going to shade above. and above would be on this side of the boundary line. So this shaded area represents my solutions. So now we're going to figure out where these points lie. So 4, 5. 4, 5 is right here. Interesting. 4, 5 is right on the line. But notice this line is a dashed or dotted line. I like to explain it as the line has holes in it. So there can't be solutions on the line because they're going to fall through the holes. So this is not a solution to this inequality. The point 0.02 is right here. That is clearly in the solution set. And the point -6, -25. Now, that's going to be, somewhere down here. But we probably need to actually count and see if we can figure out. But what we might have to do is we might have to actually plug this in to see if it actually is or not. So this point right here is -6, -16. So that doesn't quite give me a good picture of whether or not that's a solution or not. So I'm going to do it over here. So I'm going to plug in a -6 for x, so -5 times -6 plus 2 times -25 needs to be greater than -10. -5 times -6 is 30. 2 times -25 is -50. And that needs to be greater than -10. 30 minus 50 is -20. So is -20 greater than -10? -20 greater than -10? It is not. So this is not a solution because, again, -20 is not greater than -10. Make sure you double check your work. If you're using the graph, that's fine, but if the graph is not enough information, then you may need to plug things in. Also, don't forget that if it's in standard form like this example was, that you be sure that you know what side to shade.
I've been waiting way too long.